We already looked over this.
What are we looking at then? Oh, yeah, I'm sorry. I forgot where it was. All right, so here we go. On the 2.8 worksheet. Ryan, go ahead. Tell me.
Number 18 on the page.
All right, let's take a look at question number 18. All right, right here. Now, what I was saying on this particular problem here is I really kind of want everybody to be able to do this honestly in one step, right? You should be able to work backwards in your head. You're getting better at it. So you're supposed to look at this and say, I need to get rid of the divided by 7. So how do I get rid of the divided by 7? You multiply by 7. All right, then from there, all right, I have to get rid of the minus 4z. So to get rid of the minus 4z, I have to do what? Add 4z. Listen, that's how simple it is. All right, now if you don't know that, I'll put the steps up here. So this is going to be times 7, so multiply by 7. So that would be b minus 4z equals 7a. And then from there, you're supposed to notice that I should add what? 4z. Add 4z. So we know that b is equal to 7a plus 4z. However, I think you guys are smart enough that you can just look at this. And if you can't, you can tell me. You should be able to look at that equation and just solve it for b. What?
But if before you had you had to multiply by 7, so what did you divide by? Because you had 7b equals.
I don't have 7b. Show me where 7b is.
Because earlier you drew 7b.
Right. Okay, so now here's your mistake. Ready? Watch. I put a times 7 there. So what does that do to this 7 and this 7? That's why it's not there. You with me now, right? All right. Go. All right. Let's take a look at number 5. All right. Now, the reason sometimes kids have problems here, all right, is because the variable is written twice. All right. So why am I doing it?
No, because I got confused by doing it, so I didn't know if I did it right.
All right. Does anybody else need any help?
Could you do number 15?
All right. Let's take a look at 15. Now you should be better at this now because of the last explanation. So
okay.
you know. So just tell me what to do. Go ahead.
Okay. So it's x equals.
Good. Let me go ahead and write it.
2d
right?
plus c.
Exactly. And don't worry about putting it in alphabetical order right now. You know what I'm saying? That's perfectly good. The reason why now I don't care about the alphabetical order right now is because I care about you going backwards.
Yeah. Okay.
Right? That's the important part. If you were smart enough to put c plus 2d, that's perfectly fine, but that's not important. The important part is you're seeing going backwards.
Wait, so even though you put the 2d on the top and the negative c is still there, you would still change that to positive?
I have no idea what you just
Like,
said.
okay, so it's x minus c, and you put x equals 2d plus c, you would change the negative sign in front of the c.
Okay, so here's what I want you to keep in mind. I think I understand what your question is, but listen carefully just in case. So this right here, I would want you to say is a minus c. Right, that's in the way, do you agree? So if it's a minus c on the left, it's a plus c on the right.
Oh, okay.
Right? If it's a minus c on the left, it's a plus c on the right. Negatives and minuses are interchangeable. Freddie. All right, good for you. Let's take a look at 7 real quick. All right. Now, I'm going to do is I'm going to go ahead and erase this real quick. And then I want you to kind of walk me through it. You're solving for y. So what do I need to get rid of first? Oh, you're going to just go ahead and give me the answer. All right, I'm happy with that. Y equals... Uh-huh. Yes, negative x plus 1. Very nice. Over what? Be careful. Shh. Yes. Very good. That is the correct answer. All right, put your hand down and let me explain things. All right, so again, very important. This x was moved over. So it's positive on the left, so it's negative on the right. There is a what? -2 now. All right? That's multiplying -2 times y. So to undo multiply, I do what? Yes, that's the answer. All right? Now, sometimes when you take a test, what happens is your answer doesn't match the multiple choice. So I need everybody to listen up now. You need to be able to look at that and say, this is exactly the same as this answer. All right? Now watch, because here's where people make lots of mistakes. That's the same as x minus 1 over 2. Now, for those of you guys who see that, you're in good shape. For those of you guys like, I'm not 100% sure why that's true, let me come over here and demonstrate why that's true. All I did was multiply by -1 over -1. That's a legal move, right? Because -1 over -1 is 1. I'm just multiplying by 1. If I multiply by 1, nothing changes. But when I multiply by -1, I distribute, the signs change. Is everybody happy with that? All right. Now, the other thing I want you to look at is I want you to tell me that this right here is the same as 1/2 x minus 1/2. Does everybody agree with that? That's the same. Now I'm just dividing the 2 by the x and by the 1. All right, those are two really important things right there that when you take standardized tests, a lot of times kids will say, this is what I got, but this was their answer. Why is it the same?
I don't understand how that's the same.
Well, because you're dividing x. So this is technically, I'm going to go back and show you. When we were at y equals -x plus 1, when we divide by 2, we divide everything through by 2. And actually it was dividing everything by -2.
Yeah,
You see what I'm saying?
but there's no x in the 1/2.
There's no
So,
1.
like where you said x minus 1 over 2 equals then 1/2 times -1/2.
No, I said that. So are you looking at over here, or are you looking from here to here?
Yeah, I'm looking for the second one.
Right, you're looking from the second to the third, right?
Yeah.
So that's a 1 there,
Okay, I got it.
right? The number in front of the variable is a 1.
Mm-hmm.
All right? Again, that's very difficult for most kids, that particular section. All right, please review that. All right, now let's jump into the review. All right, I think I posted already for you guys, correct?
Yes.
All right. However, make sure this is it. Yes, here's where we are. All right. Now, like I said, what I'm going to do for us today is we'll try to go through and I'll try to do the odds with us, and then I'll do the evens with the other class, and then you can just listen to the video if you have some particular questions. All right. But I want to work these through with you. All right. So here we go. Number 1, 6 less than 5 times the number squared. Remember, 6 less than means you're subtracting 6. You're subtracting 6 from what? 5 times a number squared. And I don't care what variable you're using. Now for question number 3. 8 times the sum. So these are 2 operations in a row, times and sum. Whenever you have 2 operations in a row, that requires a what? Parentheses. That's correct. So it would be 8 times the sum of a number and 10. Any questions? All right. Now you're just evaluating, making sure you understand order of operation. All right. Now, I want everybody to observe carefully. All right, listen to what I'm saying. Yes, there is an order of operation. All right, but does it really matter? Listen to me. If I do this, this, and this at the same time, it makes no difference. All right, it makes no difference. All right, even technically it says we're supposed to do the parentheses first. All right, you guys are old enough now, you should understand order of operation. All right, so what's 4 cubed? What's 8 squared? So right off the bat, that's just what? 0. All right, so that was nice. So this is out. All right, now what's 36 divided by -6? And then 2 times 7. So -6 plus 14 is, so the final answer is, yeah, you guys should be good with that, -8. If you made a careless mistake, figure it out, let me know. All right, now on the point for number 7 was I just tried to throw different types of parentheses in just to try to throw you off. The parentheses are all the same, correct? All right. So now what we need is in here first. All right. So I have to do 1 to the 4th first, which is what? 1. 1 to the 4th is what? 1. 7 minus 1.
6.
3 squared. 9 times 6. 2 minus 54. What? 2 minus 54. Right. Is that right? Now, double check me on that, and if you're not sure, let's figure it out. Anybody have any issues so far?
I don't get it.
What?
How come you do 6 times 2?
Because I'm doing what's inside the parentheses first.
But then you multiply 9 times 6.
All of this is inside the big parentheses. So I did everything inside first. Because there's double parentheses, I have to do what's inside this parentheses first. So what's the question? You good or not? Okay. Now, 6 times -52 is obviously -312.
Obviously.
6 times 5 is a tough one. 30, which would be 300. 6 times 2 is 12. 300 plus 12. Slow down. All right. 312. All right. Minus. Now here you got to be real careful. All right. A lot of people accidentally put 1 there.
No.
But it's what?
It is, wait, 6. It's 36.
36.
That's correct. 36.
Wait, why would you do
So do you want to do 12 divided by 2?
do division?
Yes, you
No,
do.
isn't it left to right?
You always go left to right. You're always going left to right. Okay? So your final answer now is -348.
Oh, no.
All right. Carry on. Let's check out number 9. Name the property. Not community.
Well, I have the call, so it's okay. Oh my god.
Commutative property of addition. Number 11.
Identity.
That's right, but we're going to say it's the multiplicative identity.
Can we do like a multiply sign?
Multiplicative identity. 13 is what?
That
Is definitely the distributive property. All right, and 0 property. You guys are good with that, it seems like. All right, now we're going to simplify. All right, so when we simplify, we're going to do some distributing. All right, so this will be 3x minus 10x plus 14 minus 12. Now, again, the mistake kids make, and just highlight, the negative times the negative is the positive. All right? So now we're going to combine terms here. We end up with negative 7x plus 12. Or 2. That's what I said. Thank you. 7x plus 2. All right. On the next one, I tried to throw a couple things in there to maybe throw you off a little bit. Remember, you can only combine terms that are exactly the same. So only x's can go with what? X's. So 4x minus 5x is, yes. Then I have a negative 3xy and a negative xy, which makes negative 4xy, and then plus 9. Perfect.
Do you do it in that order?
I don't care if you mix up the order. All right. Here we go. Now checking the box here. If you want, it might be a good idea for you to put natural number starts with what? 1. So if you want, it might be a good idea to do 1, 2, 3, ... Whole number starts with what? 0, 1, ... On integers are what? Negatives and positives. So ... -2, -1, 0, 1, ... And rational numbers are just any number that can be written as a fraction. All right. And then irrational, exactly, not a fraction. All right, not a fraction. All right. So for 21, is -3 a natural number?
Nope.
Whole number?
Nope.
Integer?
Yes.
Rational? Okay. 1.6. I'm on the odds. 1.6. Is it a natural? Whole? Integer? Fraction or rational? Yes, it's rational. Okay. 25. 1.678 repeated. Is it natural? Whole? Integer? Rational? Definitely rational. Okay. Now, the only one I want to just address real quick is 26. I tried to make that so there was no pattern. Right? Does everybody see that? So if there's no pattern and it doesn't repeat, it is what? It is irrational. All right, yes.
So a number that has a decimal, it can't be a natural or a whole number?
Wow, brilliant.
So like, why is that?
Because that's the definition of a natural number. Natural numbers are called the counting numbers. 1.5 is not a counting number. Counting numbers are 1, 2, 3, 4, 5. You with me? Again, it's really not that big a deal, and I'm agreeing with you. It really is not a big deal. But when you get to advanced math, they start defining things, believe it or not, using natural numbers. All right, it's actually very important. But for now, right now, it's just a definition. Okay? All right, moving on. Yeah, I don't want to. I did 26 instead of 27. You should be able to do 27 anyway. All right, here we go. 29. All right. Now, in this case, we're going to go ahead and add 24. Now, again, the test, you're not having any calculators, so be careful. Now, I want to try to show you something here that I think is beneficial. All right, instead of adding 24, all right, I'm going to try to show you a little advanced technique here that will help some of you. All right, does 6 go into 24?
Yes.
And does 6 go into 72?
Yes.
Yeah, so if I wanted to make the numbers easier for me, I used to be able to divide by 6. All right. Now, I'm not suggesting you have to do that all the time, but I want to try to show you something. That's why some people can do the numbers in their head quicker, because they're not doing it the standard way. All right. I know all of these numbers are divisible by 6, So I can tell you that x minus 4 is equal to negative 12. And so x was equal to what?
Negative.
It's all right.
Yeah, negative 8.
X is equal to negative 8. Is everybody good with that? Any questions with that? Now, of course, if you added 24 to both sides, it would just be negative 48. And then negative 48 divided by 6 is still what? Negative 8. I just prefer working with smaller numbers. All right, so I try to make things as small as possible whenever I can. All right, does everybody see that? Now, for example, if the 72 was like 5, I wouldn't divide by 6 first because it doesn't go in evenly. All right, and you're creating a fraction. All right, here we go with 31. Here's another prime example of that. What do I want you guys to do first? No, I want you to divide. Why do I want you to divide first?
You get rid of the 7.
Yeah, it makes the number smaller. So here we go. Divide by negative 7, divide by negative 7. 2x plus 3 equals negative 7. And now from there, you should be able to say 2x equals negative 10. So x is equal to what? Negative 5. That's kind of how I want it. That's kind of how I want it.
If it's easier for us to just do it like the big numbers.
You go ahead and do whatever you want, or you can listen to me so I can try to make you smarter. That's the point.
Oh.
All right. What?
Oh, sorry. Wait.
All right, here we go. All right, 33. Again, moving things around. So 6x, right, equals negative 36. This is a 1x right here, remember?
Yeah, no, I was I didn't know you already said
Right? And so x is equal to what? So x is equal to negative 6. Good, come on. What? All right, that's okay. So what I did, I want you to remember this. I'm taking the 1x and moving it over. So if it's positive 1, subtract 1, right? This is a positive 23, subtract 23. Are you all right back there?
Yeah.
Appreciate it. All right, everything's good? All right, here we go, 35. All right, now we got some fractions, just to see how you're doing. All right. Now, right off the bat, I'm just going to move the negative 2 over here, so that's going to be equal to what? 5, right? Now, what I'm just going to do is visually show you the fraction. So we would say 5/8 minus 2/3 x, correct? So we have a common denominator of what? 24. Please stay with me. Notice what I'm doing, making one fraction with a 24. So I have to multiply this fraction by what? 3, right? So it'd be 15 over 24. Multiply this fraction over here by what? I'm asking you, what am I multiplying it? I'm not asking what the answer is. I'm saying, what are we multiplying by? We're multiplying this fraction by 8, so that would be what? Negative 16, right? So what's 15 minus 16? Right, so we would say negative 1/24 x equals 5. Go ahead.
Alright, I thought you were supposed to keep the variable positive.
Listen to me, listen to me, listen. I want you to ask me your question. I don't want you to tell me how you thought it should be. All right, because sometimes you might be wrong, James. I know it's going to be hard because I was that way too. All right, I was always right, so just let me say what I want to say. But right now, all we're doing is we're subtracting fractions. All right, so what do you want me to do differently?
Move the 5/8 and subtract 2/3 by 5/8.
Then that will be negative, James.
How would it be negative?
5/8
minus 50.
isn't Well, okay. So that you have a point there, but oftentimes the fractions are close. In this particular case, not many people know 5/8 is 0.625 and 2/3 is 0.6 repeating. So when you do the subtraction, right? So to me, it's just adding and subtracting fractions, right? I understand what you're saying. If it was 3x and 2x, you move the 2x with the 3x, right? So does everybody understand what he's saying? Right? We want the variable to be positive, but sometimes when you're dealing with fractions, it's not easy to tell which one is greater or smaller. So you could move the 5/8 to the right, and you could move the 2/3 to the left. It doesn't really matter, all right? Because I don't want to spend time trying to figure out which fraction is greater. Does that make sense? All right. So now we're just going to multiply by what? By what? No,
Negative.
by negative 24. You're going to multiply by negative 24, correct? So x is equal to what? Come on, practice your mental math. Positive or negative?
Negative.
Yes, negative 120. 5 times 20 is 100. 5 times 4 is 20. 100 plus 20. That's how I want you doing that. 120.
Wait.
You okay?
Wait, when you just did that, like, the mental math, you did 5 times,
20,
but how'd you get the 20?
24.
Oh, I just did it by 2.
Okay, here we go. Let's check out 37. All right. Now, in this case, I just literally wanted you to look at that and say that's a what?
No,
No, it's 1. It's 1. Yeah.
It's an identity. All right? And your identity means that it's always true.
Yeah.
All right? It's always true. If it was 3x minus 9 equals 3x minus 8, it would be no solution. 3x minus 9 can't be equal to 3x minus 8. All right? Whenever you see the same equation, it's called an identity. Any number that you plug in will work. All right? On all of the other problems, there's only one solution. Right? Right now, this right here will be what? Whatever number you put will be the right answer. 0 would work. 5 would work. 10 would work. Any number that you tell me will work will satisfy the equation. That's why it's called an identity. What?
That's a T and an R.
No. That's the symbol for all real numbers.
Oh.
That's the symbol for all real numbers. All right.
Mine's so good. It's like a T.
All right. 39. Here we go. All right. Now, pay attention for question number 39. Here is the way I would like for you to see it. All right? You could simplify the inside.
But you could divide by 3.
Thank you very much, James. I could definitely divide by 3. Now, the reason why I'm going to go ahead and divide by 3 is, number one, it makes the problem easier, and the numbers are smaller. So now I have 2 minus 4 parentheses 2x minus 5 equals 3 goes into 4 once with a 1 left over. 3 goes into 12 4 times. All right? Now, for those of you guys who are becoming a little bit more advanced, stay with me, eyes up on the board. I'm still not going to distribute a negative 4. I'm going to what?
Divide by 2.
Subtract 2. The reason why I'm subtracting 2 is because this is a plus 2. So I'm going to subtract 2 from both sides. Please stay with me. So this becomes negative 4 parentheses 2x minus 5 equals what? 12. Now instead of distributing negative 4, I'm now going to do what?
Divide.
Divide by negative 4. The reason I'm dividing by negative 4 because this now is attached with what? Multiplication. So now when I divide by negative 4, I get 2x minus 5 equals negative 3. Now I'm going to do what?
Add 5.
Add 5. 2x equals 2. X equals, beautiful, x equals 1. Now what I want to do quickly for you guys is I'm going to show you why that's important. I'm going to go back to the beginning and pretend like I didn't do it that way. I'm just going to work it all out the long way. All right, so I can show you how much time and how much easier it is. All right, so 3 bracket, I'm just going to write it out real quick for you. All right, now you work on the inside, so you would have 3, then it would be 2 minus 8x plus 20, 3, then that would be 22 minus 8x equals 42.
Wait, how did you get
2 plus 20,
Oh,
right? 66 minus 24x equals 42. Yes, so 24 equals 24x, x equals 1. All right? I don't care how you do it.
is the reason you didn't like divide by 2 because you could have multiplied by 2? Like the 2 was it?
The 2 and the 4 are connected, not with multiplication.
Yeah, so it's like,
So you can't divide.
yeah, that's what I wanted.
Exactly.
How
Quick.
did you get 24? Wouldn't it be negative?
No.
I moved the 42. I moved
Oh, you moved that over.
this,
Okay.
right, and the 24 over. And if you just move the 66, it would be negative 24.
Yeah.
Okay, so it'd be the same answer. All right, that's a really good lesson right there on number 39, guys. All right, 41. All we're doing on 41 is what?
Cross multiplication.
Cross multiply. So 7, open parentheses, x minus 5 equals 3 parentheses 3 minus 2x. Now, is there a shortcut on this? No, because 7 and 3 don't divide out. That's a fraction. So it's easier just to go ahead and do what? Distribute, right? So I have 7x minus 35 equals 9 minus 6x. Does everybody agree? 13x is equal to 44. Now, that's perfectly fine. 44/13. We leave things as fractions. Everybody good? Okay. What? Come on. All right, another nice problem here. I tried to throw in some fractions, but this case the fractions were easier because 2/5 x minus 1/5 x is what?
1.
Yeah, that was an easy one. All right, so now I have 1/5 x. Now I'm moving the negative 3/4 over, so that would be a plus 3/4, right? So now what's the common denominator?
12.
Now listen, I'm trying to make it so you are a master of fractions. If you don't know what I'm doing, stop and let me help you. I want that to be mental math. The common denominator is what? 12. So 2/3 is how many twelfths?
4.
8.
8. Think for yourself. 3/4 is how many twelfths? 9. 8 plus 9.
12.
If you go to high school next year and can do 2/3 plus 3/4, your teacher will think you are insane. Right? I personally don't understand how anybody can't do that in their head. All right? You're simply getting a common denominator. You need to know 2/3 plus 3/4 is 17/12. You should know that. All right? Now, to get rid of the 1/5, we're just multiplying by what?
5.
Multiplying by 5. Can I reduce anything? So, again, practicing 17 times 5. 5 times 10.
Is 50.
5 times 7.
35.
50 plus 35.
85.
85 over 12. Now, can I reduce 85 over 12? No, I can't reduce 85 over 12 because I couldn't reduce up here. Right? You can't reduce after you multiply if you couldn't reduce at the beginning. All right? Continue on. All right. Now we have some decimals. Shouldn't be that bad. All right. Now in this observation right here, we can say it would be better to move this over here, right? So that would be what? Positive 0.1x. Then I move minus 1.8. Now listen, for me, instead of doing the subtraction, I'm thinking in terms of money. So from $1.80 to $2.45, listen to how my brain works. From $1.80 to $2 is what? 20 cents. From 20 cents to 45 cents is 65 cents. So this would be 0.65. Again, you will dazzle people if you can explain that to them. I don't think that's that hard. If you listen to what I'm telling you and you want to be better at numbers, listen to what I'm telling you right now. Because the higher you get, the better you have to be at numbers. All right? So anybody have any questions with that?
Can you just say that again?
Okay, so I'm doing minus 1.8, right? Instead of coming over here and borrowing and doing all that stuff, I'm just counting up. From 1.8 to 2 is 0.2, right?
Yeah.
And from 2 to 2.45 is 0.45. So 0.2 plus 0.45, 0.65. That's what we're doing. All right. Now I'm dividing by 0.1. So let's review that. X equals 0.65 divided by 0.1. Move the decimal over once, correct? So if you move the decimal over once, it would just be 6.5. Everybody happy with that? All right. Because our answers are in, because our problem is in decimals, is it okay to work with decimals? Yeah. So 6.5. All right. Yes, quick.
What if it wasn't 0.1? What if it was 0.2? How can you do it?
Well, if it was 0.2, you would move. That's a good question. Let's do this. 0.65 divided by 0.2. I would say then you'd move the decimal over 2 spots. Remember? So it would be 65 over 20, then reduced by 5, 13/4. Right? I don't want to divide that out. You with me? All right. I definitely prefer. I definitely prefer fractions. It's easier to work with. All right. So what's next? Okay, 47. All right. Now for question 47. Does everybody see half of? But we're dealing with decimals, right?
Yeah.
So lots of ways we could do this, but let's not make it complicated. So this would just be 3x minus 4.5 is equal to, 3x minus 4.5, which is actually nice, correct? So that's called a what? That's called an identity.
And then you gotta make that little.
Yep, so I want you to get in the habit of one line, and then an R. That stands for all real numbers. What's the matter? Come on. What?
Oh, no, I spelled it wrong. I was like, how did I spell it wrong?
Oh.
But yeah.
All right, here we go. More fractions. Here we go. All right. Again, what's the common denominator, guys? 15. So let's do the mental math properly here. So how many is this? 10, right?
Yeah.
And how many is this?
12.
10 minus 12.
-2 over 15.
-2. Come on now. Make sure you're good with that. -2/15. Right? Yes, sir.
So we're to
Yeah.
divide and
Multiply by the reciprocal. So this is -15 over 2, -15 over 2. So x is equal to, the 15's cancel. Negative times the negative is a, so he's correct. 7. Pat yourself on the back, James. Very good. All right, 51. Now we're solving for B. If we're solving for B, I'm eliminating the 1/2 and the h. How do I eliminate the 1/2? Multiply by,
Reciprocal.
right, but the reciprocal 1/2 is,
2.
so 2a. So I just got rid of the 1/2. Now I've got to get rid of the h. How do I undo multiplication?
Division.
Division. So 2a over h equals b. I got you. I got you. All right. Everybody happy with that? Yes.
So how do you get like the 2 for 1/2?
Reciprocal of 1/2.
Oh, yeah.
Right? Anytime you're dealing with a fraction, multiply by the reciprocal.
So can you go over that again?
What part of it? Here we go. So I got rid of, I'm trying to solve for b. So here's what I want to do. I'll highlight b. So that means I have to get rid of the 1/2.
Okay.
So to do a fraction, I multiply by the reciprocal.
Oh.
The reciprocal of 1/2 is 2.
Oh, okay.
And to undo a multiplication, I do what? Division.
Oh, okay. I thought we were doing
All right. Let's look at 53 now, please. Solving. All right. Here we go. We're solving for x. So if you want to highlight x. All right. This is pretty much a one-step equation. All right. You should be able to do this whole thing. All right. So I want you to say x is equal to.
It would be y minus b divided by.
You are amazing.
Wait. Okay.
Go ahead. Come on.
So.
Just a minute, Connor.
You moved the b, not the y.
Yes, I moved the b. So the
Because I
b
did the
becomes
opposite. I did
negative
the
b.
y.
And isn't it supposed to be alphabetical order though? Like,
Now listen, that's not a bad idea. It's a good thought too, but believe it or not, there's another rule that says generally you put the subtraction after. All right, guys. Fantastic job. Fantastic job. Finish up, guys, as much as you can.